Hi there, basement clean out. I'm playing with some old junk again. This time we have Microvax 3100 Model AT from Digital Equipment Corporation. The problem here is the machine doesn't start. There are no lights. Here you have 8 diagnostic lights that should light up. And as soon as I unplug the discs or the disc power, the machine works. So my assumption was there is something wrong with the power supply. The usual suspects, capacitors, because this machine has was perfectly working 2 days ago, including all 3 drives. So I assumed that one of the capacitors, or maybe 2, have gone bad. So I will remove the power supply, open it and replace all the capacitors. The machine is from 1992, so it's now more than 30 years old, and maybe it's a good moment to replace capacitors anyway. As it turned out later, the capacitors were not the problem, so even these 32-year-old capacitors were still good, but at the end of the video you will see what the actual problem was. The removal of the power supply is relatively simple. You have 2 screws on the side and then 2 captive screws in the front and in the back, and you can lift it off. A little bit more problematic is the removal of the drive tray, because the SCSI cable is very short, and you have to pay attention not to rip the cable or drop the drives onto the main board. But the power supply itself is quite serviceable. you have to remove all these connectors. Everything that goes through this sheet metal here has to go, so also the cable with the large connector then, but that has a slot to remove it from the case. These AMP connectors here are a little bit tricky, but if you push in one side they will snap, and then you can push it through from the other side. And of course everything is plugged except this connector here, which is soldered. That's the 220 volt output for a monitor, a switched output for monitor, terminal, or whatever you want to connect to your Microvax or Vax station. They have the same power supply sometimes. The power supply board is finally out, and we have to check how many capacitors we need. There are two here, one on the board, another one on the board. The large ones I leave in place. They are normally not a problem, at least with this kind of power supply. Then all the capacitors here around this transformer, they have to go. The blue Philips capacitors too, and that one here, that's the last one. When I repair power supplies, especially replacing capacitors, and there is no technical documents about, I draw a little sketch with the position of all the capacitors with their values and where the plus and minus pole is positioned. So that helps a lot, because then I can remove all the capacitors in one go and replace them later, and I still know which one belongs where. We have a large stock of new capacitors. It's 3 drawers full of all kinds of sizes, values, voltages, and we usually have those that go to PC main boards. There are a few values that you absolutely need to have, and for the power supply it's mostly the same values. For example, 1000 microfarad, 25 volts or so, 3300 microfarad, and so on. After replacing the capacitors, I checked the board for cracked solder joints. As I said, this board is now 32 years old. There are heavy components on the mounted, and yeah, it was not necessary to redo any solder joints, so they were all quite good. The AMP connectors here are a little bit tricky to install, but the plastic is still elastic, so after 32 years, no problem at all. Okay, it's time now to test the power supply in the Microvax. And as you can see, they shaped the case of the power supply in a way so that it slides in easily. They actually had in mind that it is possible to repair this power supply, or at least exchange it and then repair it. So it's a little bit different than today's machines that are not really built for repair. And here we go again for this SCSI connector. It's a high density connector which is in fact SCSI in and out in the same connector. So we are making a loop here with this SCSI bus. A loop that ends on the back panel, on the terminator there. And as you can see, it's not so easy to get this connector into its socket. The problem is also it's dark down there, and the connector is black and the socket is black too. Yeah, you need a little bit of patience. Connecting the terminal to console port 0, and as you can see, here goes nothing, because the problem was not the power supply. And here I unplugged disk number 3 and the machine is running again. So it turned out that the problem was actually hard disk number 3. I do a little show device here, and you can see 2 disks are active, one is unplugged. You can see the power plug there hanging around the disk. I have to check that disk now. By the way, the sounds of this disk is absolutely normal. They have been loud when they were new and they are still a little bit loud. That's how they work, so nothing to worry about. I'm here at the disk test station with a little bit stronger power supply, and you can see what happens when I turn it on. The magic smoke escapes, and it smells exactly like a SMD capacitor. Trust me. See, I'm right. There are two capacitors, one for the 5 volt, one for the 12 volt supply, and one of them has decided to end its life here. So I have to replace that, and I will replace the other one too. Okay, it's time to test it again inside the machine. Let's see if it's still smoking or not. I expect it not to smoke because it has new capacitors now. Should be fine. And the blinking lights are blinking as they are intended to be. Everything is fine. Self-test is running, 40 megabyte of RAM, and show device tells us maybe there are 3 disks. The only problem is DKA 300. It has no size. The other two are 426 megabytes. That's a problem for another video.